We're going to continue our subject of finding slopes, finding and interpreting slopes. So today's notes you can find on page 5 in your purple packets, the unit packet that goes along with chapter 4, section 1 in the textbook. So finding and interpreting slopes of a line, day 2. So use slopes to compare two unit rates, because as we learned in 7th grade, a unit rate, y over x equals that k, that constant of proportionality, was called the unit rate last year. This year we're going to be calling it slope, and we use the letter m to represent that slope. The graphs give information about the distance d traveled over time by two automated toy trains A and B on a straight track. Which train moves at a slower rate of speed? Well, the slope of the line, or the steepness of the line, may give you some insight to which one's going faster and which one's going slower. So it says, which train moves at a slower rate of speed? If I find the slope of the line of train A, I can see that my rise is going up 30 and over 1. So I'm going 30 millimeters per second. That's the train A unit rate, the rise over the run. The slope of the line of toy train B, well, if I start here and my other points here, I'm going up, read your axes carefully, up 20 and over 4. So 20 over 4 reduces to 5 millimeters per second. So the slope for the distance moved by train A is 30, or 30 millimeters per second. The slope for the distance moved by train B is 5. So 5 millimeters per second. Train B has the slower rate of speed. And we can tell that by the steepness of the line. Remember, rise over run, y over x, is the slope or the steepness of the line. Also, that constant unit rate that we talked about last year. The graphs give information about the distance d over time, t, by two ball bearings A and B of different weights rolling down a ramp. Which ball bearing has a faster speed? So this time, which one has a faster speed? So the first ball bearing A here, my first easy to point read, although any of these are really pretty easy to read, I can see that from this point 0, 0 at the origin going up 50 and over 1, I see my rise is 50, my run is 1. But I could have, again, used any two easy to read points. I could have used the point 2, 100 and the point 3, 150. Again, going up 50 and over 1. So the ball bearing A has a rate of 50 millimeters per second. That's its speed. Ball bearing B, I can see this is an easy point to read. The end point here is an easy point to read, or the origin is an easy point to read. So we can use any one of those two pairs of points. And I can see that going from the origin, I would go up 50 and over 2 here. So ball bearing B has a rise of up 50, but a run of 2 over 2 units. So B has the 25 millimeter per second speed. A has the 50 millimeter per second. So A, ball bearing A, has the faster speed. And yes, the slope for the speed moved by ball bearing A was 50. So that's a 50 millimeters per second. The slope for speed moved by ball bearing B is 25. So the unit rate is 25 millimeters per second. Unit rate, y over x. Y over x equals k, that constant of proportionality called the unit rate. And page 7. However, you do not need to draw a line to find the slope of a line. Given any 2 points, x of 1, y sub 1, that could be the first point A, and b x sub 2 y sub 2 is how you read that. On a line, you can find the rise and the run by subtracting the coordinates. So this is what I call the delta y over the delta x, right? The delta symbol, we make a difference because it does mean subtract. We are the different airline. Delta means different. So slope rise over run, or y sub 2 minus y sub 1 over x sub 2 minus x sub 1. You're going to see me write delta y over delta x. So, find the slope of the line through each pair of points. And this is how I do it. So I write m equals for slope, and then I write my symbol delta y over delta x, because I don't like to write y sub 2 minus y sub 1 over x sub 2 minus x sub 1. I shortcut it and say delta y over delta x. As long as I'm consistent, and that's what this note down here says. When you find the rise or the run, it does not matter whether you subtract the coordinates of the first one, A, from the second one, B, or the other way around. What does matter is that you use the same order for both the rise and the run. So subtract your y values exactly the same. So I kind of do this. Oh, 7 minus 1, and I'm subtracting y sub 2 minus y sub 1. 7 minus 1, so I cannot do 4 minus 2 on the bottom. I have to do 2 minus 4. So I get 6. 2 minus 4 is negative 2. So my slope is negative 3 over 1. And yes, I'm going to leave it negative 3 over 1. You can change it to slope m equaling negative 3. Notice I always write m equals. That means slope. Delta y over delta x. So this time I'm going to go in this order. I'm going to subtract first point minus second point. So negative 1 minus negative 7. Ooh, careful there. Over x. X is on the bottom. Remember, get the right order here. 4 minus negative 2. So I get negative 1 plus 7, which is 6. And 4 minus negative 2, which is 4 plus 2, which is 6. So my slope is 1 over 1. Letter C. Delta y over delta x. 6 take away negative 2 would be my change in my y values over negative 3 minus 1. I'm out of space here. Whoops. Negative 3 minus 1, so that would give me 6 minus negative 2 is 8. It's going to get cut off here. 8 over negative 3 minus 1 is negative 4. So my slope here, m equals negative 2 over 1. That's the answer for C up there. Got to write smaller. D. M equals delta y over delta x. And again, be consistent. So negative 5, I almost always do second point minus first point. So negative 5 minus 0, and yes, you should show this math. Don't shortcut it. 0 minus negative 8. Be careful. Be careful with those integers. And yes, you get negative 5, and 0 minus negative 8 is 0 plus 8. So negative 5/8 is my slope. E. Delta y over delta x. So 4 minus 7. And no, you don't have to draw these little arrow things like I'm doing. Negative 3 minus negative 2. It's just a little thing that helps me make sure I'm consistent in the order, what this little note down here is talking about. And I get negative 3 minus negative 2 is negative 3 plus 2, which is negative 1. So yes, my slope is 3 over 1. I'm going to leave F for you to do. So let's do this one. I'll check at your notes tomorrow. Make sure you're being consistent on how you are subtracting and that you are doing y over x, not x over y. And that's it for today.